Welcome to this lecture. This lecture is on Laplace transform. Laplace transform is an important topic. It has got many applications in maths, physics, and many engineering fields like electrical engineering, signal processing, and more importantly for our control engineering. So before we study process control or control engineering, you should have a good knowledge of Laplace transform. You need not have, even though you need not have a very in-depth knowledge, but you should have good sufficient knowledge about Laplace transform, because the whole process control needs Laplace transform, and Laplace transform has a major application in process control. So in this lecture, let us see what is Laplace transform and some of its properties and the transform of some important functions. Well, how is it defined? So the definition of Laplace transform is this. If you have a function f of t, the Laplace transform of that function is defined by this relation. L is a symbol for Laplace operator. L is a Laplace operator. So L of f of t is defined as an integral of this function f of t into e power minus st the integral limit between 0 and infinity. So when you do this, carry out this integral operation, this f of t will be converted into function in another domain. This function in t domain will be transformed into another function in another variable s. So it is transformed into s domain. So in our course control, we will take this t. Normally this t is time. So a function in time domain f of t will be transformed to function in s domain. We call that as frequency domain. So function of t by making Laplace transform, it is transformed into a function of s. It is in a function. It turns into a function in s domain or frequency domain. So this is the definition of Laplace transform. How do you transform a function into, by means of Laplace transform, how do you transform this from t domain to s domain? So this integral is an improper integral, and this f of t may not exist for all functions. This integral may not exist for all the functions. But we need not worry about that. For our process control, all the functions required in our process control can be transformed. So this f of t, there is that the functions which do not obey this, which cannot be integrated by this, they will not come in process control. So in process control, whatever functions we come across, they can be integrated by this, and it can be transformed into s variable, right? So this is the definition. Now let's see a property of this Laplace transform. One is the Laplace transform of a constant into a function will be equal to the constant multiplied by the Laplace transform of the function. That is L of alpha into f of t. Alpha is a constant. It will be equal to alpha into L of f of t. Another property is the Laplace transform of sum of two functions, the Laplace transform of sum of two functions like this will be equal to the sum of the Laplace transforms of the two functions. I repeat, the Laplace transform of sum of two functions will be equal to the sum of the Laplace transforms of these two functions. That is L of alpha into f1t. This should be f1 here. Alpha into f1t plus beta into f2t should be equal to alpha into L of f1t plus beta of L of f2t. So the L of alpha into f1t, this is f1t, is f1t plus beta into f2t equal to alpha into L of f1t plus beta into L of f2t. So let me write it. Okay, so since that subscripts of f1t is not very clear, so let me write L of alpha into f1t is f1t plus another constant beta into f2t will be equal to alpha into Laplace of f1t plus beta into Laplace of f2t, or you can also say alpha into f of s, f1 of s plus beta into f2 of s. So these two rules are called, these two properties are called together called linear property. Okay, these two properties are called linear property. Okay. These two, this one and these two, called linear properties. Okay. Now let us see some examples, one or two examples using this. For example, when f of t equal to 1, f of t equal to 1. Now what will be the transform of this? So when we say f of t equal to 1, algebraically we represent it as u of t. So it's called a unit step function. Okay, we will see more about this later. I am just mentioning here. We will see about this in the subsequent courses, chapters. So when f of t equal to 1 or f of t equal to u of t, u of t means 1. So what will be the Laplace transform? So let us apply this formula. L of f of t equal to integral 0 to infinity. F of t is 1 into, if we use this formula here, whichever is this formula, f of t in d power, this formula if we use 1 into e power minus st into dt. So we know this e power st minus st is integral of that is minus e power minus st by s. If you put the limit 0 to infinity, what will you get? The first limit e power minus infinity becomes 0, minus of minus plus, second limit minus of this minus plus, put 0, it becomes e power 0 is 1, so 1 by s. So the Laplace transform of f of t is 1 by s. Okay. So this is just simple illustration for simple function, illustration of this root, this formula. L of f of t is 1 by s. Okay. So we'll see more examples later. Now I'll give you a table of transforms for some basic functions which are required in our course in process control. Use all of them using this formula. Okay. When f of t is 1, the Laplace transform of is 1 by s, as you have seen just now. Transform of 1 is 1 by s. Transform of t is 1 by s square. The transform of t power n, where n is any integer greater than or equal to 1. The transform is factorial n divided by Sn plus 1, s power n plus 1. This is factorial n divided by s power n plus 1. Transform of t power n is factorial n divided by s power n plus 1. So next is root of t. Root of t is transform is root pi divided by 2s power 1.5. Then another common function which will come quite often in our course is e power minus at. The Laplace transform is 1 by s plus a. Then sinusoidal function sin kt, transform is k by s square plus k square. Cosine function cos kt, transform is s by s square plus k square. Hyperbolic function sin h kt, transform k by s square minus k square. Cos h kt, cos hyperbolic kt, transform s by s square minus k square. Then we have another function f of t multiplied by e power minus at, where f of t can be any function. Then f of t multiplied by e power minus at, the Laplace transform of this whole thing, Laplace transform of f of t into e power minus at is f of s plus a. That is, first you write the transfer function of, first you write the transform of f of t, which is f of s. Then in that you replace s by s plus a. So this rule is known as translation of function, because this rule is known as translation of transform. This rule is known as translation of transform, because the transform f of s is translated into f of s plus a. Transform of f of t is f of s. Transform of f of t multiplied by e power minus at is f of s plus a. So if you apply this rule, let us apply this rule and write the transform of some functions. So let us write for t into e power minus at. First you write the transform of t. Transform of t is 1 by s square. Then in that replace s by s plus a. So the transform now is 1 by s plus a whole square. Transform of t into e power minus at using the above rule is 1 by s plus a whole square. then e power minus at into sin kt. So sin kt is like this f of t. So write the transfer function of f of t sin kt. Sin kt transform is k by s square plus k divided by s square plus k square. So in this replace s by s plus a. So what do you get? You get k by s plus a whole square plus k square. Replace s by s plus a, you get k by s plus a whole square plus k square. Same way, e power minus at into cos kt. This cos kt is like f of t. So write the transform of cos kt. Transform of cos kt is s by s square plus k square. So in this, replace s by s plus a. S is there in two places, numerator as well as denominator. In both places, replace s by s plus a. You get s plus a divided by s plus a divided by s plus a whole square plus k square. You get s plus a divided by s plus a whole square by s plus a divided by s plus a whole square plus k square. So this is illustrating translation of transform. Next we will see another rule, f of t minus t naught. F of t minus t naught. So the transform of this is f of s multiplied by e power minus st naught. F of transform is f of s into e power minus st naught. That is, you write first the transfer function of f of t, which is nothing but f of s. Then multiply this f of s by e power minus st naught. So this rule is known as translation of function. This rule is known as translation of function. F of t minus t naught transform is f of s into e power minus st naught. So this rule is known as translation of function. Translation of function. So let us see why it's called translation of function and what is the meaning of f of t minus t naught. What is the meaning of f of t minus t naught and why is it called translation of function? If this is f of t, any function is a curve or a straight line or any curve or any random shape, any function, this is f of t, only thing starting from 0, starting from origin 0. If this is f of t, then the same curve, identical curve, but only thing whose origin is shifted from 0 to t naught, whose origin is shifted from 0 to t naught. Okay, then that function or that curve is known as f of t minus t naught. I hope it is clear. If f of t is a curve or a straight line or anything, it can be even a straight line starting from 0, then the same curve shifted from origin 0 to t naught, instead of starting from 0, it starts at t naught. That function is known as f of t minus t naught. So, one more, it can be anything. It can function can be curve or a straight line or anything. For example, if it is a straight line, f is 0. Suppose if this is straight starting from 0, if this is f of t, then the same curve which is shifted by t naught, this will be f of t minus t naught. Okay, so this is t axis. So if the Laplace transform of this f of t is f of s, Laplace transform of f of t is f of s, then the Laplace transform f of t minus t naught is this. Okay. Laplace transform of f of t is f of s, then the Laplace transform of f of t minus t naught is f of s into e power minus st naught. T naught is this. So this rule is known as translation of function, because the function f of t is translated from origin 0 to another origin t naught. It originates from t naught instead of from 0. I hope it is clear. Next we will go for derivatives. What will be transform of derivatives? This is the first derivative. This is the first derivative. One of the major applications of this Laplace transform is in solving differential equations, solving ordinary differential equations, ordinary linear differential equations. So one major application of Laplace transform is in the solution of ordinary linear differential equations. So it is important that we remember what is the transform of derivatives. So this is the first derivative, f dash t, f prime or f dash t, or df by dt is the first derivative. So what is the Laplace transform of the first derivative? It is s into f of s minus f naught. So f of s, as we know, is the Laplace transform of f of t. S is s variable, domain, s domain variable. F0 is the function. F0 means f of t evaluated at t equal to 0. F0 means f of t evaluated at t equal to 0. F of t evaluated at t equal to 0 is f of 0. Now in the same way we will see for nth derivative. Now if we see for nth derivative, dn f by dtn is the nth derivative. The Laplace transform of this is a equation starting from nth power of s power n into f of s minus s n minus 1 power s power n minus 1 f0. Remaining terms all will be minus. First term positive, remaining terms all will be negative. Then minus s power n minus 2 f dash 0 minus s power n minus 3 f double prime 0 minus s power n minus 4 f triple prime 0, and so on, so on. The last term will be f n minus 1 at 0. So the 0 are all initial values of the function. Prime indicates derivative. Like I said, prime indicates derivative. F prime 0 means here. F prime 0 means first derivative evaluated at t equal to 0. Similarly, f double prime means second derivative evaluated at t equal to 0. So like that this equation goes on. So that is the meaning of all these primes here. This. So this one. So all these things prime f double dash 0, f double dash 0, all these things mean this. And f n minus 1 0 means f n minus 1 0 means n minus 1th derivative evaluated at 0. Okay, hope it is clear. So this is a Laplace derivative of Laplace transform of nth derivative. Now next we will see Laplace transform of an integral f t dt in the limits between 0 t, the time interval 0 to t is simply fs by s. There is a small thing here. This means this is f of s is the same as capital F of s, that is the Laplace transform of f of t, that is this is f of s, small f of s is the same as capital F of s. Quite often, even though at the beginning I said L of f of t is capital F of s, quite often, that is f in the uppercase, quite often small f is also used invariably. In the remaining lecture we will be using small fs invariably, and small fs means same as capital Fs. Same capital small fs is same as yes. This small f of s should not be considered as simply f of t replaced by s. It is not f of t in which t is replaced by s, but the presence of s variable means that this function is the Laplace transform function of f of t. So there is no specific need of using capital F. The beginning I had used capital F to be more clear, but in the subsequent analysis we may be using small fs for convenience than capital Fs. Small f, I repeat, small f, this term. This does not mean that t is simply replaced by s. This term f of s means it is Laplace transform function. Presence of s indicates that is in s domain, which means it has been Laplace transformed. Okay, so that should be clear. So we'll be using fs, invariably fs and small fs as same, both are same. So we'll stop with this in this lecture. I hope you have understood. Please share this video, subscribe to this channel and leave your comments below. And we have a lot more to do in Laplace transform, which we'll see in the subsequent following lectures. So please, if you subscribe to this channel, you'll have notification of the other videos coming to you. You'll be knowing when the other lectures are coming up. So please subscribe to this channel and share it to your friends. See you till then.